Welcome back to Science 10. You would have just finished the discussion on the natural greenhouse effect, so now we'll look at the greenhouse effect lab or inquiry. So the question or the problem, how does the greenhouse effect help to maintain temperature? Hypothesis, the greenhouse effect results in more absorption of thermal energy and reduces the amount of thermal energy that radiates back into space. So that's kind of what our prediction is going to be, that we're going to set up a mock greenhouse here by having one thermometer in a bottle, one thermometer out, and absorbing radiation from a lamp. So what should happen here inside our model of Earth here, with the bottle representing the atmospheric gases surrounding the Earth versus having nothing. So variables in this experiment, you'll be measuring the temperature change inside and outside the bottle, and of course we're manipulating and responding variables, which you'll answer here later on. So you can see the materials here, folks. Carefully insert one of the thermometers inside. Yes, secure the thermometer, etc. And then with the clamp, attach a second thermometer to a stand like this. Position the heat lamp so it's equal distance from both thermometers. So that's important. This picture looks like that the lamp is closer to this one, but it's actually an equal distance from both. So we want to make sure that is the same. And then our model should look like that. Create a data table that will allow you to record the temperature change inside and outside the bottle every minute for 15 minutes. Turn the lamp, record the initial temperature, then at 1 minute intervals, and then we'll continue that for 15 minutes. Okay. Analyzing and interpreting. Graph your results. Plot the time in minutes on the horizontal axis and the temperature on the vertical axis. Use a solid and dashed lines to distinguish between the two temperatures, or have some other way of labeling it, just like we did in the previous angle of incidence lab. Compare the temperature changes that occur inside the bottles to those outside. Explain any differences you see. So was there any difference between these temperature readings versus these? Number 3, explain why the temperature eventually stopped rising inside the bottle, referring to the energy coming in and going out. Was the bottle a good model of the natural greenhouse effect? Identify the limits of the model in your answer. And then number 5, describe how you could use the albedo of different substances to generate a higher temperature in the bottle than recorded in this activity. So what are some things you could do in terms of albedo, i.e. substances that reflect or absorb radiation? What could we have done with the bottle to make the temperature higher that's being received from the lamp? Assuming the lamp is the same distance away, what are some things you could have manipulated to make the temperature go up inside this bottle? All right. So just like the last one, we have the lab handout here. So the greenhouse effect, so purpose, what do you want to find out? Hypothesis, it's kind of given to you in the sheet there. Just simply look back. What is meant by the greenhouse effect? So you may have to go back and look at this region here, which clearly describes what is meant by that. In terms of materials, procedures, safety, just simply put as per text. Our data tables, similar to last time, except we only have 2 of them. Temperature inside versus outside the bottle. So the thermometer inside versus the thermometer outside. So start off with 0 minutes, record the temperature, turn the lamp on, and then continue on until 15 minutes has passed. And the usual conclusion, what was the purpose? What did you think would happen? And then what did happen? Was the hypothesis correct? And then, then lastly here, if you take a look, answer those questions that I just discussed, questions 1 to 5 from the handout on our loose leaf. So those questions 1 to 5 are these ones right here. So question 1 was making the graph itself, and then all the way up to 5. All right, we'll see you again.